Hello and welcome to my channel. I am Mensa Augustine. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and you have not yet subscribed, please kindly subscribe for us to build the mathematics community. In this lesson, we're going to look at infinite series of real numbers, and we'll be looking at special series. And this special series is a geometric series. So we'll be determining the convergence or the divergence of a geometric series. Now, in general, the geometric series is being given in two forms. You have summation from n equal to 1 up to infinity. A times r to the power n minus 1 equals a plus a times r plus a times r squared plus dot up to infinity. And you can also write it in the form n equal to 0 up to infinity. A times r to the power n equals a plus ar squared plus up to infinity. Now the geometric series converges if the absolute value of r is less than 1, or the r lies between -1 and +1. It diverges if the absolute value of r is greater than or equal to 1. And if it converges, then the sum of the geometric series is equal to the first term divided by 1 minus r. R is the common ratio and a is the first term. So the sum of the geometric series is equal to a divided by 1 minus r. Now let's go through the following examples to determine the divergence and the convergence of a geometric series. Now if you take the first one, you have summation from n equal to 1 up to infinity, 2 exponent n divided by 100, which is equal to summation from n equal to 1 up to infinity, 1 divided by 100 times 2 exponent n. Wow, we have to write this either in this form or in that form. But this one, since n equal to 1, it is good for us to put it in this form. Wow, so here, if I have 2 exponent n, I can subtract 1 and add 1. Minus 1 plus 1 is 0. We are proving it towards this formula. That is why I've subtracted 1 and added 1. Very simple as that. So this one can be written as summation from n equal to 1 up to infinity, 1 divided by 100 times 2 exponent n minus 1 plus 1. Wow, from the product law of exponents, if I have a exponent x plus y, it is a exponent x times a exponent y. So this one can be written as summation from n equal to 1 up to infinity, 1 divided by 100 times 2 exponent 1 times 2 exponent n minus 1. Wow, very simple. 1 plus n minus 1 is the same as n minus 1 plus 1. So here we have summation n equal to 1 up to infinity, 1 divided by 50 times 2 exponents n minus 1. So this has been put into this form. So we have r equal to 2 and a equal to 1 out of 50. Now, if we take the absolute value of r, that's the absolute value of 2, then the absolute value of r is equal to 2. Wow, and this 2 is greater than 1. So if the absolute value of r is greater than 1, then the series diverges. Hence, this geometric series diverges or is divergent. Now let's look at the second one. For the second one, we have summation from n equal to 1 up to infinity, -2 divided by 9 all to the power n. Since you have n equal to 1, you have to put it into this form. That will be more simple for us. So here this is the same as summation from n equal to 1 up to infinity, -2 divided by 9 exponent n minus 1 plus 1. Minus 1 plus 1 is 0, as we've done in the first example. So this will give us summation n equal to 1 up to infinity, negative 2 divided by 9 exponent positive 1 times negative 2 divided by 9 exponent n minus 1. So we've put this into this form. So here we have a to be equal to negative 2 divided by 9 and r equals negative 2 divided by 9. Now the absolute value of r is equal to the absolute value of negative 2 divided by 9. So here the absolute value of r is equal to 2 divided by 9. So if we point 2 divided by 9, we are going to get 0.22222, which is less than 0. Sorry, which is less than 1. The absolute value of r is less than 1. So this value is less than 1. Hence, the series converges. And if it converges, let us find the sum of the series. Now, the sum of the series will be given by a, and a is negative 2 divided by 9, all divided by 1 minus 2 divided by 9, and this will give us negative 2 out of 11. Use your calculator to check. That is minus 2 divided by 9 divided by 1 minus is plus 2 divided by 9. That will give us negative 2 and 11 as the sum of the series. Very, very simple as that. Now, let's check the third one. Now, for the third one, we have summation n equal to 1 up to infinity 2 exponent n times 3 exponent n, that's 1 minus n. Now this one is very simple for us to do. Okay, so here 2 exponent n, so we have summation n equal to 1 up to infinity 2 exponent n minus 1 plus 1. Wow. But what about 3 exponent 1 minus n? Let's factorize the negative sign out. So we have 3 exponent negative, and this one will be negative 1 plus n. Because negative times negative will give us positive. Negative times positive will give us negative. So this one can be written as 3 exponent negative into bracket n minus 1. I've just rearranged. Wow, this is the positive n and this is the negative n. So we check that. Very, very simple as that. And if we have this from the properties of indices, if I have 3 exponent negative 2 is the same as 1 on 3 exponent 2. So this one is the same as 1 on 3 exponent n minus 1. Wow. So let's go here. So this is the same as 3 exponent 1 negative into bracket negative. Okay, let's negative into bracket n minus 1 because you've explained it here. This is the same as summation n equal to 1 up to infinity 2 times 2 exponent n minus 1 times 1 divided by 3 exponent n minus 1. So this is the same as summation from n equal to 1 up to infinity 2 times 2 exponent n minus 1 all divided by 3 exponent n minus 1. And this will be given as summation from n equal to 1 up to infinity 2 times 2 on 3 all to the power n minus 1. So here a is equal to 2 and r equal to 2 on 3. Very, very simple as that. So let's check 2 divided by 3. No, let's find the absolute value of r. The absolute value of r is equal to the absolute value of 2 on 3, and that is 2 on 3. So if we divide 2 by 3, wow, that is 0.66666, which is less than 1. So this is 0.66666, let's approximate this to 0.667, which is less than 1. So the series converges. So if it converges, let's find a sum. So the sum of the series will be given by 2 divided by 1 minus r, that is 2 on 3. And this will be given as what? Let's use the calculator to go fast. You have 2 divided by 1 minus 2 on 3. That is 6. Very simple as that. Now let's check the fourth one. For that one, we have summation from n equal to 0 up to infinity, 5 exponent n divided by 8 exponent n. Wow, this is very simple. You can put this in this form. Simple. So we write summation from n equal to 0 up to infinity, 5 on 8, all to the power n. Here the coefficient here is 1, so we can bring times 1. So here we have a equal to 1 and r equal to 5 on 8. The coefficient of this is 1, so we have times 1. That will give us a. So here the absolute value of r is equal to the absolute value of 5 on 8. And that is 5 on 8. And 5 on 8 will be less than 0, since the denominator is greater than the numerator. So here 5 divided by 8, 0.625. So here 0.625 is less than 0, meaning that the series converges. So if it converges, let's find a sum. So we have the sum up to infinity, 1 divided by 1 minus 5 on 8. And from the calculator, we have 1 divided by 1 minus 5 on 8. Wow, and that is 8 on 3. So here the series converges to 8 on 3. Very simple as that. Now let's check the fifth one. Here we have summation from n equal to 1 up to infinity, 2 exponent n times 2 exponent 1 minus n. Wow. So this one, you've done it already. Oh, sorry, this is 2. So here, what do we do? So here, we take the summation from n equal to 1 up to infinity. This is the same as 2 exponent n plus n. Wow. 2 exponent n plus n. Should we do it that way? No. If we do it that way, we will still have the n attached to it. So, if you have 2 exponent 2n, the same as 2 exponent 2 to the power n, which will give us 4 to the power n. Let's do it that way. So, we can write this one as summation 4 to the power n. And if I have 4 to the power n, I can subtract 1 and add 1. Minus 1 plus 1 is 0, as we've done before. So I can take minus 1 plus 1. And this one will be written as 2 exponent negative into bracket n minus 1, as we've done earlier in the other examples. So we are going to have this one as summation from n equal to 1 up to infinity, 4 times 4 exponent n minus 1 times 1 divided by 2 exponent n minus 1. And this will give us summation n equal to 1 up to infinity, 4 times 4 on 2, all exponent n minus 1. Very, very simple as that. So here we have a to be equal to 4 and r to be equal to 2. Because 4 divided by 2 is 2. So here the absolute value of r is equal to the absolute value of 2, and the absolute value of 2 is equal to 2. So this is greater than 1. So since the absolute value of r is greater than 1, then the series diverges. Very simple as that. Check how we had here. 2 exponent 2 is 4. So you have 4 exponent n. So you can subtract 1 and add 1. So we take 4 exponent n minus 1 plus 1, which is the same as 4 times 4 exponent n minus 1. And here we have 2 exponent y minus n, which can be written as 2 exponent negative n minus 1. If you send the negative inside, you come back here. And this can be written in this form. This time this will give us 4 exponent n minus 1 divided by 2 exponent n minus 1, which can be simplified to this form. That is that. Now let's check the 6th example. Wow, the 6th one. Okay, let's see. Now the 6th one, we have a summation from n equal to 1 up to infinity, 3 exponent negative n times 8 exponent n plus 1. Wow. So how do we do it? We have n equal to 1, so we put it in this form. So here, we can do it this way. By writing this as summation n equal to 1 up to infinity, we will take 3 exponents negative n, let's add plus 1 minus 1. Okay, and then we have this one, right? So we take 8 exponent n plus 1. Let's add plus 1 minus 1. Because plus 1 minus 1 is 0. So let's move on. We have summation from n equal to 1 up to infinity. Let's consider this one. That will give us 3 exponent negative into brackets n minus 1. And here we still have our minus 1. Times 8 exponent n minus 1 plus 1 plus 1 is 2. Wow. So here, from the laws of indices, we can write summation n equal to 1 up to infinity, 3 exponent negative into bracket n minus 1 times 3 exponent negative 1 times 8 exponent n minus 1 times 8 exponent 2. If we add the powers, you come back here. If we add the powers, you come back here. So this one is very simple for us to do. So this will give us summation from n equal to 1 up to infinity. This one will come down. We are going to have 1 divided by 3 exponent n minus 1 times 1 divided by 3. Wow. Times 64 times 8 exponent n minus 1. Wow. So we are going to have summation from n equal to 1 up to infinity. We have 64 divided by 3 times 8 to the power n minus 1 divided by 3 to the power n minus 1, which is equal to summation from n equal to 1 up to infinity, 64 divided by 3 times 8 on 3 to the power n minus 1. Wow. Very simple as that. So here we have a to be equal to 64 on 3, and we have r equals 8 on 3. Now the absolute value of r is equal to the absolute value of 8 on 3, and that is 8 on 3 is greater than 1. Check and see. That will give us 2 point something. Yes. That will give us 2.66666. So 2.666667 is greater than 1. Hence, the series diverges. The series does not converge, it diverges. Very, very simple as that. So, let's check the 7th example. Now, for that one, we have summation from n equal to 1 up to infinity, negative 1 exponent n minus 1, all divided by e to the power n. This one is very simple. So we will take the summation n equal to 1 up to infinity, negative 1 to the power n minus 1, all divided by e to the power n, then we subtract 1 and add 1. So this is the same as summation from n equal to 1 up to infinity. We are going to have negative 1 to the power n minus 1, all divided by e times e to the power n minus 1. This is e to the power 1. So 1 plus this, we come back to here. So it is the same as summation from n equal to 1 up to infinity, 1 divided by e times negative 1 to the power n minus 1 divided by e to the power n minus 1. So this will give us summation from n equal to 1 up to infinity, 1 on e times negative 1 on e, all to the power n minus 1. Wow! So here a, that's the first term, is 1 on e, and the common ratio r equals negative 1 on e. And let's take negative 1 on e. So for my calculator, I'll write, I'm going to point, I'm going to point negative 1 divided by, divided by, which will be less than 0, right? Divided by e. That is negative 0.367. Yes. Which is here is within this interval. It's within this interval. So here the series converges. The series converges. If you want to check that within that interval, you have negative 1 and positive 1. So 0 is here. So here, negative 0.1, negative 0.2, negative 0.3, negative 0.4, negative 0.5, negative 0.6, negative 0.7, negative 0.8, negative 0.9, up to negative 1. So negative 0.36 will lie between negative 1 and positive 1. So the series converges. So since the series converges, let's find a sum. The sum up to infinity is equal to a, that is 1 divided by e, all divided by 1 minus 1 on e. And that will give us 1 on e divided by 1 plus 1 on e. And this will give us 1 on e divided by e times 1 is e plus 1 divided by e. And this will give us 1 on e times e divided by e plus 1. This will cancel this. We have 1 divided by e plus 1 as the sum to infinity of the series. Check how we did here. Just simplify the denominator. 1 plus 1 on e is simply e plus 1 divided by e. Then this division sign is here. So here we turn this upside down and change the division to multiplication. Very, very simple as that. So let's check the 8th one, and I think the last one will deal with it in a very simple manner. Now, the eighth one is a summation from n equal to 1 up to infinity. We have 2 exponent n divided by 3 exponent n plus 1. Wow. So here, this in a very simple term, we take summation from n equal to 1 up to infinity, 2 exponent n plus 1. Okay, let's subtract 1 and add 1. So we have n equal to 1, so we are putting it in this form, divided by 3 times 3 exponent n. Wow. From the loss of indices or the loss of exponents. So here for the n, you can subtract 1 and add 1. Wow. So this will be equal to summation from n equal to 1 up to infinity, 2 times 2 exponent n minus 1, all divided by 3 times 3 times 3 exponent n minus 1. Because 3 exponent n minus 1 plus 1 is the same as 3 exponent n minus 1 times 3. So this 3 is what I've written in front here. Don't confuse yourself with breathing and respiration. Breathing is just the movement of the chest that allows the intake of oxygen and output of carbon dioxide. But respiration is a different thing altogether. Okay, so here we take this one to be equal to summation from n equal to 1 up to infinity, 2 divided by 9 times 2 exponent n minus 1 divided by 3 exponent n minus 1, which can be written as 2 exponent 3 or exponent n minus 1. And you have this in this form. So here you have a to be equal to 2 on 9 and r equals 2 on 3. And 2 on 3, if we take the absolute value of r, we will still get 2 on 3. If you divide 2 on 3, it will be less than 1. So the series converges. And if the series converges, let's find the sum. We take the sum up to infinity, 2 on 9 divided by 1 minus 2 on 3. This is the same as 2 on 9 divided by 3 minus 2 on 3. This is the same as 2 on 9 times 3 on 1, because 3 minus 2 is 1. And that will give us 2 on 3. Wow. Let's use the calculator to check. We have 2 divided by 9. 2 divided by 9 divided by 1 minus 2 on 3, which is equal to 2 on 3. So the sum of the series up to infinity gives us 2 on 3. Now the last example. Hope you've enjoyed this lesson. Kindly subscribe to my channel, share my videos, like, leave your comments, and let's go to the mathematics community. So let's tackle this one. This one, the simplest among all. We have summation from n equal to 1 up to infinity. We have 5 times e on 3 exponent n. So this will give us summation n equal to 1 up to infinity, 5 times e on 3 exponent n minus 1 plus 1. Wow. So this is the same as summation n equal to 1 up to infinity, 5 times e on 3 exponent 1 times e on 3 exponent n minus 1. So here we have summation from n equal to 1 up to infinity, 5e on 3 times e on 3 to the power n minus 1. So you have a to be 5e on 3 and r equals e on 3. So the absolute value of r is equal to the absolute value of e on 3, which is the same as e on 3. So let's check e on 3 on the calculator to see whether it is less than or greater than 0. So e on 3 is 0.90. So let's take less than 0.9. 0.9 is less than 1. So the series converges. And if it converges, let's find the sum. So the sum up to infinity is equal to A. That is 5e on 3 divided by 1 minus r. That is the common ratio. And the common ratio is e on 3. Wow. So here we have 5e on 3 all divided by 3 minus e divided by 3. That will give us 5e on 3 divided by, okay, let's do times 3 on 3 minus e. So this will give us 5e divided by 3 minus e. Very, very simple as that. So you can point this on the calculator and leave your answer in decimals. Thank you for watching. Please kindly subscribe to my channel, like, share my videos, and leave your comments for us to build the mathematics community. You can follow me on Facebook, Math with Vim. Bye bye.